So Revit's just a 3D modeling program whereby I just kind of went through and constructed the plotting layout of the whole device and how it would come together, and making sure that every piece would kind of fit together properly and would leave just enough space. The idea was to try and minimize as much materials used so that it was reducing the costs. But again, that it would just make sense in terms of the way that it operated and would look, I guess, aesthetically pleasing as well. So let's see. So each thing was designed in Rhino 5, and then it was outputted for a laser cutter. So all the acrylic pieces that we see in here are, of course, laser cut, which typically you can find access to a laser cutter in most major cities. Either someone's offering it as a service, or it's usually very easy to find, say, a hackerspace or a DIY workshop space where you can learn how to use it and then make laser cut acrylic pieces very easily. And then the boxes were designed, and then they had to be adjusted for the tolerances of the laser cutter, because as I mentioned, acrylic does have a lot of problems, mainly that the width of the acrylic actually is not a very precise material to work with, especially when we're talking about the joints. Let me just show you really quickly if I fast forward a little bit. So these are some of the plotting layouts for the laser cutter for making 10 units at a time. And then this is for making 4 units of the drying rack at a time. And again, it was designed to be very efficient in terms of the cutting, reduce time and costs as much as possible. Let's see. And then this is the final unit, of course. Sorry. Yeah, this is what I was mentioning before. Part of the problem with working with acrylic is that even though this is a 3/16 acrylic that the box is made out of, it's actually not really 3/16 all the way through. It has a tolerance of about 1 millimeter, which when it comes to these snapping joints is really complicated to deal with, because if it's not exact, then you either have a very loose construction of the box, or you're ending up with pieces that just crack and break. So part of the problem is that everything had to be designed so that it could be snapped together easily using these kind of weird acrylic joints. It's like a kind of a natural spring. And then each piece also has to be filed down manually, which is a bit problematic as well, because there's a lot of labor involved in terms of having to file down each joint of the box. But each one was designed for that. For this, these rubber ground rods, they just snap in and out like this. So it's easy to just put together. And then the rollers were designed also to work for a variety of different purposes. I won't bother really going through every purpose for it, but this was just designed as a Super 16 roller so that there was as minimal contact to the film as possible. So yeah, the operation. So usually the box just comes unassembled, so that you can transport it. So I just have one that's completely unassembled here. So again, it just comes with a few different pieces and a minimal amount of hardware. So yeah, it's quite compact, so you can travel with it very easily. But it just comes together kind of just by snapping the pieces in, so you can just kind of see through this kind of a slide presentation how I'm putting it together. Just snapping in the pieces individually to create the box. And then the roller assembly comes apart so that you can, of course, clean it very easily. So the idea is that all these are in separate pieces, and then you just have to put it together in terms of putting the rollers on, and then just attaching the squeegee by just pressing it through these joints, and then you have your complete little roller arm thing. So then when it comes to loading the box, you just put a daylight spool onto that back, the spring-loaded rod at the back of the unit. And then it just gets screwed on, of course. And then it gets drawn over the initial feeding roller, like this. And then if you imagine your emulsion is in this beaker that you've just placed into the box, you just draw the leader over it, and you take your roller arm, and you just push it in, like this, so that the leader is registered onto the roller, and then it just snaps into place. and then it's ready to go. Then you just basically draw it onto here, and one run for 100 feet usually takes about 8 minutes or 9 minutes. And the results are very consistent. So if I can just show one more video example of that. I'm actually going to forward to our negative. So this was the negative that was created with the very first one in knots. In the very beginning, there was some bubbles that had formed on top of the emulsion. So these are getting drawn off, and then it becomes quite consistent. And in fact, the film, after you process it, it looks just like a 7302, as if you had just used commercial print style, which again is both a good thing and a bad thing, because you lose a lot of the aesthetic qualities of the hand coating of the emulsion. Anyways. So yeah, you get an idea of how consistent the results become of this. Okay. And then, let's see. Yeah, so this also I just wanted to show really quickly as well. I did design it so that it could be used with a different variety of beakers or whatever reaction vessels that people choose to use for their emulsion making. I tend to use a 250 milliliter beaker, but I also designed it so that it would fit a stainless steel tank, which is also very convenient, and it typically is like kind of like the entry-level way of people making emulsion as well. And then I also just designed it with like a small few other features, like namely that it has like a position for holding the thermometer inside the beaker so you can measure the temperature of the emulsion. I also designed it with mine that you could cement together the box itself if you intend not to take it apart, so that you could form it as a water bath to maintain or have a more consistent temperature for the emulsion. Though I found that in 8 minutes, typically the temperature doesn't actually change enough to warrant the need for a water bath, and you just go and it coats quite evenly. And then besides that, initially it was designed for a double strand operation, or to have 2 film strips running through it at a time, but that's proved a little bit difficult. Really quickly though, I just wanted to show the cost breakdown of the box, because again, it was very important to me to try and keep it as cheap as possible. And so this is just a breakdown of all the parts that are involved and the cost of making it per unit, and then in terms of just like total investment of making a certain number of boxes. And in the end, it works out to being about $20.41, one coating unit. That's without a drying rack. The drying rack is also like another $20. So altogether, you could buy both of them, and it would be $40 essentially. And of course, we do these things like on a volunteer basis. So we do ask for suggested donations, but the idea is that if it's like you're an artist and you can't afford it, you just pay the amount that it costs to make the device. So yeah, it worked out to being fairly cheap for what we needed. Okay, and then just final thoughts would be success and failures of the device. So part of the criticisms of it are, of course, that because it is cast acrylic and it is all these snap together joints, it does have a feeling of certain fragility to it in some degree. But I've made more than like 5 of these now and have used them over and over again and haven't found that any of the pieces break per se. But there's always, it could of course always be more durable than cast acrylic. It just tends to be the cheapest thing. The labor involved is a big issue because each unit takes me about like 5 hours to put together or so, because even once you have it run through the laser cutter, because of all the tolerances that I mentioned before in terms of the width of acrylic and the tolerances of the laser cutter, you have to individually file down each of these joints to make sure that they're not going to like snap together or snap apart once you throw the machine together. And then I already mentioned the dual strands problem, and then also the debate of aesthetics in terms of like, is it really the point of hand making emulsion for it to come out looking like 7302 or something like that? And then also the availability of certain materials has been proved to be a problem in terms of like both the spring, for example, that's used in the back there. It's a bit complicated to find a spring that works exactly in the right amount of quantities. It's just springs in general are very difficult to source. The squeegee, of course, is from a processing machine. And these were all donated from Global Now, which happens to have like just massive boxes of them, but of course one day those will run out, and then after that there won't be any alternatives. And then also just the rollers are of course custom made, and it's not really like something that anyone can just go and have made for them very easily down the road or something like that, and very cheaply. These ones cost €7 to make in Portugal. Before that I was getting quotes that were like $20 a piece or something like that. And before that I was also using steamek rollers that were just being recycled from dead ski units, and it worked out great as well. So, but again, there's a problem with availability of certain materials. And then the reperforation of the sprockets never really worked out, like I mentioned, trying to basically break the surface tension of the emulsion as it exited the device. Never really seemed to work out. And then also, there's the problem that to use this in the operation that I've kind of described, where you have the leader just coming up onto the drying rack, you do tend to need a second person at least to be helping you with the coating process.